Hi, everyone. Good morning, good afternoon, and good evening. We are going to kick off this webinar in just a few minutes, so please be patient. We've got lots of people joining right now. You are in the right place. Today's webinar is Next Gen SCA, Securing Modern SDLCs with Pipeline Composition Analysis. So we'll kick things off in 1 or 2 minutes, so thanks for your patience. For those of you who are just joining us, you are in the right place. This is the Next Gen SCA Securing Modern SDLCs with Pipeline Composition Analysis. So we will kick off the webinar in about 1 minute. We have a whole bunch of people who are still rolling in, and we want to give them an opportunity to go on the journey with us. So thanks for your patience. All right. I think we're probably in the clear to go ahead and kick things off. So welcome to today's webinar. Today's webinar is Next Gen SCA, Securing Modern SDLCs with Pipeline Composition Analysis. Just a couple of housekeeping items before we get into things. So this webinar is being recorded. We usually send a recording out within 24 hours of the conclusion of the webinar, so look for an email. And then if you have questions or comments, we would love to hear from you using the questions tab on the GoToWebinar panel. So if you think of anything, send it our way. What we will plan to do is to do a Q&A session at the end of this session and address as many questions as we have time for. Other than that, we can go ahead and kick things off. So Julie, you want to move us forward?
Sure.
All right. We have 2 speakers today. Julie, want to introduce yourself?
I would love to. I am Julie Peterson. I'm a Senior Product Marketing Manager here at SciCode. I have been working in tech for quite some time, and my past employers include companies like Mend, formerly White Source Software, IBM, and IBC.
Awesome. Thank you. My name's Orion Cusetto. I'm VP of Product Marketing here at SciCode. Like Julie, I've got quite a wealth of cybersecurity experience with just over 15 years in the industry. Much of that time is spent in application security and security operations. My past employers include Exabeam, Imperva, Distill Networks, and several others. So why don't we go through our session agenda? So today we'll be talking about a number of topics. First and foremost, we'll be talking about what is a software supply chain attack and how you can address them and the security challenges that come with them. We will then talk about software composition analysis, or SCA. We'll give you a quick overview of what it is, and then we'll talk about what its role is in relation to software supply chain security. We'll talk about where it falls short and what capabilities could be added to it in order to fill those shortcomings. Then at the end of the presentation, we'll review pipeline composition analysis and its capabilities and its role and how it can help you to secure your software supply chains. At the very end, we will go into a Q&A and answer as many questions as we have time for. Julie, do you want to kick us off?
Sounds great. Yeah. So we're going to start with addressing software supply chain security and the challenges that it brings, right? So we're all here to talk about securing our modern SDLCs, and as we all know, software supply chain attacks have been growing in prevalence, right? So we're seeing a rise in not only the numbers, but also the sort of the intensity of attacks. Attackers are staying in systems longer and doing much more damage from SolarWinds on. And it's at the point where Gartner is predicting that by 2025, nearly half of all organizations worldwide will have experienced some sort of attack on their software supply chain. And that is a 3-fold increase from just last year. So it's a big problem now, and it's just growing. So we really need to pay attention to it. So, why is the supply chain such a big problem? Well, the short story is that attackers are shifting their priorities from production applications to the software supply chain. And the reason that they're doing this is that we've done a fairly decent job of focusing on our applications in production and locking them down. And attackers are just like the rest of us. They're going to go after the easy, not the hard. They're going to go after something that has a big bang for their effort. And right now, the software supply chain is all too often overlooked and not secure enough in most organizations. Not only that, but what attackers are finding is that they can infiltrate one company and then spread an attack downstream to many. So it's a big bang for their buck, and they can live in the systems for much longer undetected. So that's why we're seeing this increase in software supply chain attacks. Now, before we move further, I just want to make sure that we're all on the same page when we talk about what a software supply chain is and what it means to secure it. And so I thought I would start with creating an analogy that looks at what a traditional supply chain looks like, right? We're all pretty much familiar. In this example here, it's a car, right? So think of it as like a Ford F-150, right? Ford has a number of in-house components that they build themselves, think, like the engine, drivetrain. But they also outsource and use a number of third-party components to build their car or their truck. Brake pads, a sound system, various bits and pieces that they get from outside of their homegrown solution. And then they have the manufacturing line that is assembling everything. So it's taking all these bits and pieces and actually assembling it into something that will run. And then finally, you have your workers who are putting everything together. And the bottom line here is that each of these components are important. If there is a defect or a flaw in one of them, you're going to end up with a substandard truck coming out the other end. And so all of the components come together. They're really equally important. Now, if you look at the software supply chain, it does a pretty good job of matching up against a traditional supply chain. So you can think of the custom code that you build in-house as your in-house components. Your dependencies like open source components or third-party software are your third-party components. Your DevOps tool and infrastructure, right? So, think build tools and, beyond the things that put everything together, that aligns nicely to your manufacturing infrastructure. And then finally, your developers are your workers. They're the people who put everything together. So today, we're really focusing on this dependency piece, right? So it's what software composition analysis focuses on. And it's a really important piece because it's something that you don't necessarily control when you're putting your software together. You can inspect open source packages and make best decisions. You can certainly look at third-party components, but there is a lot of unknown, which is why you need software composition analysis as a tool to scan these dependencies. Open source is a unique thing where a vulnerability could be released at any time. It might be several years after a library has been widely used. And I think of like the dirty cow vulnerability. That CVE was something that lived in the Linux core for more than 8 years. It was written by Linus himself, and somebody discovered it. And so, it's something that you really need to be vigilant about and look at your software composition analysis to make sure that you're securing these dependencies. So what is software composition analysis? It is an AppSec tool, and it does 3 main things. So the first thing it does is it takes an inventory of all of your open source components. The second thing it does is then find all of the licenses associated with each component so that you can make sure that you're not using any restrictive licenses that might require you to make derivative works downstream publicly available, right? We're trying to sell our solutions, and so you want to make sure that you don't have something like GPL licensing in your code base. And then the third thing that software composition analysis does, and you can argue that this is perhaps the most important thing it does, is that it scans your open source code for known vulnerable dependencies. So it will look at your open source libraries, compare it to things like the NBD, and then give you a list of things that are vulnerable. Now, one of the things that many SCA tools also do is they have the ability to create a software bill of materials. And software bill of materials are really useful. So they're a machine readable inventory of all of your components. And they allow you to be transparent with your downstream customers. So you can tell them, hey, this is everything that's in our software, and gives your downstream customers the ability to make the assessment about whether you're safe and secure to use it. Now, we're seeing a lot of talk, particularly over the last year and a half, over software bill of materials because there was a White House executive order last May that basically said any software company doing business with the federal government has to provide a SBOM in order to do business. And what we find in the market is that when the federal government makes an edict or puts out a standard of doing business, that it sort of becomes the default way of doing business. And so Gartner is saying that, sort of imminently, this will be just the way everybody is expected to do business, that when you supply your software, you're also going to be given a software bill of materials with your product. So with this software bill of materials, SCA vendors have done a really good job of co-opting this term software supply chain security, in that they're saying, hey, we're giving you everything that makes up our software, we're giving you transparency into the components, and therefore you can understand your software supply chain. But I think what we're going to argue here is that while software composition analysis is important, it actually doesn't go far enough. It doesn't really provide you with full software supply chain security. It might be good at looking at certain types of exploits like dependency confusion, but when you look at where the attacks are happening in the software supply chain, software composition analysis is just one of the many attack vectors. So this image here is an outline of the Google SALSA framework, and what it shows you is that there are a lot of different ways to infiltrate the software supply chain. Now, over here on the left, you can see software composition analysis. It's focusing on your vulnerable code dependencies. And it's just one of many ways into the software supply chain. It's extremely important, but on its own, it's not going to give you everything you need. That being said, we feel that software supply chain security can be enhanced if software composition analysis is expanded to include more dependencies and more parts of your software supply chain. So what we're here today to talk about is the next generation of software composition analysis. So where current software composition analysis solutions fall short, and how we can expand upon it to do this piece of supply chain security much better. So again, I'm going to start with some of the shortfalls we see and how you can improve upon it with pipeline composition analysis. So pipeline composition analysis takes the promise of software composition analysis and applies it across your entire pipeline. So the first challenge that we see with software composition analysis is that AppSec tools often are stuck in silos. And in the case of software composition analysis, what it's doing is it's hyper-focused on your application code, and it's hyper-focused on the open source components in your application code. Now, it does a really great job on that, but unfortunately, it doesn't have any visibility into various parts of your SDLCs. So it can't really tell you what's going on in the build process or in your artifactories, right? So it's really focused on application code, and because of that, you're lacking the greater context of what's going on from a security standpoint. And as we know, anybody in security can tell you that you're inundated with alerts from everywhere, and so greater context will help you make sense of those alerts. What pipeline composition analysis does that software composition analysis doesn't is it gives you complete visibility over your SDLC, right? How can you secure something if you can't see it? So what pipeline composition analysis does is it ingests and analyzes data from all the tools that make up your software delivery pipeline. So, your source control, your build tools, artifactories, all the way to cloud. And what pipeline composition analysis does is it connects and correlates the dots from all of the data from these tools, things like activity and events, usage and permissions, configurations, and even the security controls of those tools. And the result of this is an end-to-end visibility of your entire development environment and software pipeline. And it can take the context from your pipeline and enhance the data, both the scans coming out of your software composition analysis, but then also take the data from these other tools and help you make sense of the risk involved for your software composition analysis scan. So again, complete visibility is the key starting point for pipeline composition analysis. Orion?
Yeah, thanks, Julie. So the second challenge of software composition analysis comes down to the type of vulnerabilities that it's looking at. So it is squarely focused on application code dependencies. And so if we move forward, I'll dig a little deeper into that. Okay, so essentially there are many types of dependencies that pop up throughout your SDLC. If you think just broadly for a second about what we mean by a dependency, it's essentially something that you don't create or own or even maintain necessarily, but it is in use either in your code base or in the process of making your software. And so, when we think of dependencies, the first one that comes to mind is code dependencies. Here we're talking about, open source libraries and open source components. So those components can have vulnerabilities in them. And so when you use those open source libraries in your software, essentially that vulnerability ends up in your software and you have that vulnerability. And so SCA does help with this. This is kind of its core capability. So that's great. However, there are other types of vulnerabilities. The first type is the dev tools themselves. So these are the tools that make up your software delivery pipeline. Oftentimes people aren't thinking of them as a dependency because it's just a tool that you use to facilitate your software creation. But think for a second. So your SCM or your build tool as an example, they fit that definition, right? They are, things that are used that you don't control, that you rely on to make your software, and if you have a vulnerability, could lead to a breach. So it's, kind of in that same bucket. Now, these tools themselves, your SCMs, your build tools, your container registries, etc., if they have vulnerabilities in them, can be a problem. And we've seen it out in the wild. There are some very famous examples and some recent examples of this happening. One of them, Team City. So that is a build tool made by a company called JetBrains that once upon a time had a vulnerability that ended up being very famous because it caused the SolarWinds incident, right? The SolarWinds incident was because Team Cities was compromised through through a vulnerability. More recently, we've seen other examples of this. So the little news blurb above that is about GitLab, which is a source control management system, one of the more popular ones. It had a security advisory about a vulnerability that allowed for remote code execution. That's just not the sort of thing that you want happening in your SDLC. But the point here is if you can understand that you're using a vulnerable version of these tools, you can upgrade to a non-vulnerable version of those tools once a patch has been made available. And so it's the exact same concept that of how you would deal with an open source vulnerability. It's just applied to DevTools. Now there are other types of vulnerabilities. The next one is plugins to those DevTools. So an example here is plugins to things like Jenkins, right? So Jenkins has plugins. Circle CI has orbs. There's many examples of this, but think about it in the same way that you think about a browser extension or a browser plugin, right? It's something you can get out of a marketplace that extends functionality of that tooling. Again, it's something that you're using that somebody else creates, and it becomes part of how you build software. These plugins themselves can have vulnerabilities. In July, there was a security advisory where a couple of dozen plugins were found in the Jenkins marketplace that had vulnerabilities in them. And so it's again that same concept. You need to understand, for the tooling that you have, and what plugins exist, what versions of those plugins exist, are those versions vulnerable? And if so, you need to either stop using them or upgrade to a non-vulnerable version. As you kind of move through your software delivery pipeline, there become other types of vulnerabilities. So as we start to do build workflows, you end up with build modules. What I mean here is something like a GitHub action or a GitLab runner. These are, kind of automated steps and actions that happen in your build tool. So these, you can get them usually out of a marketplace sort of a situation. You use them in your product, and they're, created and maintained by a third party. For example, it could be, CodeQL, it could be Red Hat. The one that we have here is an example, try in web IDE. This is a GitHub action, and it is maintained by Red Hat. Now, they are just like other code, right? They are, essentially code written to do automation in your build tool that is maintained by another company. So that could have a vulnerability in it, but kind of moving forward a bit, they are written just like normal software, and essentially your build module is going to be some percentage custom code written by Red Hat or whoever else, but also a whole bunch of open source libraries and components that they suck in, because that's just how software is made these days. And so they can bring in frameworks and libraries and open source components that have vulnerabilities in them as well. So it's kind of another layer of dependencies. The final example I'll give you goes in a little bit of a different direction, but same concept, is infrastructure as code. So infrastructure as code is used to provision infrastructure, cloud infrastructure, in kind of a repeatable software fashion in an automated way. And your IAC files can have scripts in them. They can bring in packages. Those packages and components can have vulnerabilities in them. And so it's just another way that you can bring in a third-party component that could be vulnerable. And the big takeaway here is essentially that there are many types of vulnerabilities that can be that can pop up throughout your SDLC that could be vulnerable, and you need to do something about it. And that is one of the core capabilities of pipeline composition analysis. It takes the idea of looking for vulnerable, kind of third-party components and open source components, and it expands it to all the other types of vulnerable dependencies that may pop up. So, this allows you to kind of, better align your security measures, reduce the risk of overall breaches. And so the core capability here is find vulnerable dependencies and think, not only in your code, like you'd get with SCA, but in the rest of the types of vulnerabilities in your pipeline. All right, Julie, over to you for the next capability.
Yeah, great. So the third challenge that we see with software composition analysis is that it has limited visibility into vulnerability locations. And what do we mean by this? So software composition analysis is really effective at identifying vulnerability locations in application code itself. However, it can't tell you where that code has been deployed in production. So once it's out and built, it can't tell you where it's gone. And why is this an issue? Well, if we look at something like Log4j, which was widespread, ubiquitous, that's a really good example of not being able to see vulnerability locations, right? So Log4j came in on a Friday afternoon, ruined a lot of security professionals' weekends, in that they were scrambling to find the patch, update the code, update the library, and then push it live into production. So the companies that were most successful in doing this were ones that had done a sort of audit of their environment and knew exactly where every piece of code had been deployed onto, which server, in which data center, in which location, right? And they were able to kind of then contact the people who managed those different machines and make sure that, instances where the vulnerable instance was spun down, that was the new instance with the fix was spun back up, and that they were secure. It had to be a manual process. There's no way to automate it using traditional software composition analysis, because they don't have any visibility where the code goes once it leaves your SCM. And the problem with this is that you can't determine whether all your vulnerabilities have been remediated in a production instance. So, you're kind of hoping that you've got everything, but there is no way to definitively see. I mean, if we go back to challenge number one in the visibility, right? Software composition analysis can't see your whole pipeline, so it can't track these vulnerabilities and tell you that yes, you've remediated everything that needs to be remediated. One of the great capabilities of pipeline composition analysis is that it understands your whole pipeline and therefore can understand exactly where your vulnerabilities have been deployed in production locations. So if you go back to that log4j example, if you recall, it took 3 tries to actually get an update that fixed the problem, right? So there was a patch immediately, sort of that Friday evening, Saturday morning that was pushed. And then Monday, they realized they hadn't quite gotten everything and there still was an open path to the vulnerability. And then finally, later in the week, they had a 3rd one. So think about it, right? You're having to not only patch your code and push it and then contact everybody, but you have to do it 3 times. And guess what? Probably every application used that library because it was so ubiquitous. And again, a hugely manual process. By being able to understand the full location, pipeline composition analysis can automate this process. So you can then look at your production environments and understand, like, yes, actually, guess what? It's been remediated every place that I need it to be remediated. So you're able to be more agile in your response times, and you're able to ensure that your remediation is fully complete and that you are not vulnerable for your applications in production, which is, a huge, anybody who's been through it hands-on can tell you that this is an amazing time saver. The 4th challenge that we see with software composition analysis is around prioritization. We know that there's a lot of noise out there. We know that the number of vulnerabilities is increasing, right? Open source is 80 to 90% of modern code bases, and you can't do everything immediately, so you need a way to effectively prioritize. Software composition analysis has done this mainly by focusing on the code and the vulnerability information itself. So the first way it's done this is by looking at CVSS score, right? Every CD is released with a CVSS score of low, medium, high, or critical. Unfortunately, the truth of the matter is that more than 50% of all CVEs are released with a CVSS score of either high or critical. And when everything is a 5-alarm fire, nothing's a 5-alarm fire. Like when everything is important, nothing is important. And so it's actually really of limited use in practicality. So what a number of software composition analysis vendors have done is they've tried to improve upon prioritization based on whether a vulnerability has a path from the code itself to the vulnerable function. And so if we look at this, this idea of reachability, this top level here shows the squares, the rounded squares are your open source libraries, and the triangles inside that is the function inside. Libraries have many functions, right? And so functions will often call their own dependencies, right? It's the problem of transitive dependencies in open source, right? And that library might call its own dependency. And here, the vendors have found a way to say, okay, this function calls another function, which in turn calls a third, which then actually calls another dependency. And oh, by the way, that dependency has a known vulnerability in it, and your code is calling it and exercising it in production. And so you know that this is something that you need to make a priority at this time. There are instances where perhaps you're calling a library with a known vulnerability in it, but you're not actually calling the function, which is shown in this second path here, right? So you have one dependency, a second dependency. It is calling a function in that library, but not one with a known vulnerability. So this is a case where you can effectively deprioritize this particular vulnerability because it's not impacting you when your application is live. And again, this third path here shows you, a similar thing, but though there's a function in the second dependency, it actually doesn't call a dependency with a known vulnerability. So again, you can effectively deprioritize that. So while this is one way to help cut down the noise, pipeline composition analysis actually goes one step further and expands prioritization to include whether a vulnerability is exploitable in your runtime environment. So it looks at your cloud environment and tries to understand everything that you have in play and whether a vulnerability is exploitable in that. And I'm going to give you an example here of Spring for Shell. So Spring for Shell is a vulnerability out there, similar to Log4j. That's widely used, but it needs a very specific environment, very specific conditions to catalyze to make the vulnerability exploitable. So it needs like a job development kit of 9 or higher and a whole bunch of other things. If you don't have all of these conditions in play, you cannot exploit this vulnerability, and so you can safely deprioritize it. And so this is the advantage of being able to see the whole pipeline and understanding what's going on. You can, again, bring a finer view to the environment and again, cut down on the noise and focus on things that are actually exploitable. So instead of spending a lot of time remediating Spring for Shell, you don't have the right environment to make exploitable. You can then move on to something that is actually a real risk to your organization. Orion, back to you.
Sure. The last challenge we want to talk about today comes into play when we start talking about different tools, development tools as a type of dependency. So software composition analysis really has no understanding of the tools that are being used to create your software and how they're configured and what security controls exist in those tools. This is a problem because if you think about it, right, you have a software delivery pipeline. It is owned and assembled and maintained by your engineering team. These are essentially development tools, right? So you've got a team, your engineering team, they have a skill set and a job they need to do, and based on that, they go and they select the tools they need to create that pipeline. So they're going to get an SCM, a build tool, container registry, a cloud provider, etc. Now, all of these tools are essentially they're developer tools, so they are set by default to enable developers, right, for efficiency and productivity, not necessarily for security. And so what this means is that oftentimes, some of the settings are, not configured in a way that would be secure or in accordance with best practices. Now, this problem becomes worse when you think that, hey, my organization may have multiple engineering teams. They all have their own, software delivery pipelines. Oh, by the way, if you perform M&A activity and you purchase a company that is a software vendor or creates software, then you get their teams and tools. And so this becomes a lot to wrap your arms around. Just making sure that your configurations of the tools and the security settings and the posture here doesn't, essentially facilitate or enable something that could cause a breach. And in fact, it's actually super easy for that to happen. What we're talking about is the basics of security, but frankly, it doesn't happen. A good example is the New York State Office of IT, and essentially what happened is that they had a GitLab instance, which is an SCM, so the first column there, code. Their GitLab instance was online, and essentially it had a misconfiguration in it, and it was a really easy misconfiguration, but it had some really dire consequences. What happened was anyone could go to their GitLab instance publicly on the internet. They could sign up and create an account. Then they could assign themselves admin privileges and have full reign of everything that was in, all the repos, all the intellectual property, change any settings they wanted. They had full control over the SCM. And so, that is a perfect example of just one little misconfiguration and how it can create a really big problem. And so SCA really has no understanding of, how these tools, these dev tools, can create other types of vulnerabilities that could lead to a breach that aren't necessarily code-based. And so that is a capability that pipeline composition analysis can offer. So pipeline composition analysis essentially is integrating with all these tools. It understands, how they relate to each other, the activity that's happening in them, the configurations, the security controls. And it can look at those and say, are all of these tools configured in the appropriate way? Do they have the right security controls? And it can help you to use those same APIs that are facilitating, the data ingestion to reach back out to those tools and to help you to, automate the securing or hardening of your pipelines in these tools. And so it could be things like, helping you to review access privileges and enforce least privilege, or it could be, enforcing branch protection rules, or, strengthening your authentication settings, and a number of other things that would help to prevent these tools from being an attack vector, essentially. So that is the fifth capability. Now, if we look at all of these things together in aggregate and we say, all right, so from what we've learned from all those other examples, what actually is pipeline composition analysis? Well, here's what it is. Essentially, it is the idea of software composition analysis, but it's a superset. It's expanded to your entire pipeline. So it does everything that SCA does and more. And that more is, better visibility by understanding what's happening in all of your SDLC tooling, understanding your software delivery pipelines, what activity is being taken, what are the settings of the tools, etc. It is able to provide you better breadth or greater breadth because it can identify more types of vulnerabilities in more places, not just your open source libraries and your licenses. It can help you with remediation, both in terms of faster remediation because you understand what you need to fix both at a code and a deployment level, but also did you fix it? It can help you with more complete remediation because you can answer the question, do I still have log4j? Am I still vulnerable to this specific vulnerability? It can help you with prioritization because it expands from the tools of prioritization that you would get with SCA to new ones, including runtime exploitability analysis, and then help you to actually secure the tooling themselves. So closing the tools themselves as a new type of attack vector that could be vulnerable. So this is the premise of pipeline composition analysis. We've covered a lot today, so a quick session recap before we go into a Q&A. By the way, this is a great time to start adding questions into the GoToWebinar control panel, and we'll start answering them in just a minute. But a quick recap, so software supply chain attacks are a large and growing problem. These are the SolarWinds types of attacks. Securing third-party components, things like open source libraries and other types of dependencies, is an essential part of software supply chain security. It is not the only thing that you need to do. If you remember Julie's slide that had all those attack vectors, there's other things that you need to do. However, dealing with dependencies and vulnerable dependencies is super important because it's helping you to wrap controls around something that you inherently don't control. Those are components and things that are maintained and built by other people. And then pipeline composition analysis is a really good way to, for that piece, for that world, to expand upon the capabilities of an existing tool set and to offer a whole bunch of new capabilities. That includes, greater visibility, more types of vulnerabilities that you can detect, better prioritization, a better understanding of those vulnerabilities' location, and then the ability to understand, again, the actual settings of the tools and whether they could be an attack vector. Okay. One slide before we get into our Q&A, a quick slide about SciCode and who we are and what we do. So we are a complete software supply chain security solution. We have a suite of tools. So there's 8 tools that we offer that essentially help to plug all the different attack vectors that could be used to create a software supply chain attack. On the vulnerability detection side, there's 4 tools there. SAST to help you to find vulnerabilities in your custom code, Next-Gen SCA or pipeline composition analysis, which we talked a lot about today, to help you to find vulnerabilities and dependencies, container scanning to look for vulnerabilities in your containers, and infrastructure as code scanning to find vulnerabilities in infrastructure as code and your templates and files that might turn into a vulnerability in your cloud infrastructure. On the other side of things is a suite of tools that we call pipeline hardening, but essentially what it has in common is there are tools that help to keep attackers out, to harden your tooling to keep the attackers out, and to prevent breaches. And that's pipeline security and governance, looking at configurations and tooling, code tampering prevention, which is looking at all the different handoffs that happen through the phases and the tools of your software delivery pipeline, and making sure that code is going through those handshakes and maintaining integrity along that journey. It's looking for hard-coded secrets across your entire SDLC and looking for code leaks. So your code being leaked out into public sharing sites like github.com. All of this sits on top of a graph database backend we call our knowledge graph that allows us to connect and coordinate between all of these different tools and with the tooling of the SDLC. that is it. So we will shift gears and we'll go into Q&A. So we see a whole bunch of them coming in. So let's see here. I'm just going to start at the top. First question. Somebody's paying attention. Doesn't SCA scan during the build process? Doesn't that help protecting the software supply chain? Julie, do you want to take that one?
Yeah, I can answer that one. So yes, SCA can scan at a number of different phases of software development. I think the thing to remember here, though, is that it is scanning code. So yes, it can scan as part of your build if you have that integration, but it's not actually looking at the build tool itself or any plugins that might be brought in by that build tool and all of the things that pipeline composition analysis expands upon. So again, it's doing the same thing. It's focusing on your application code. It's just doing it at a different point in the development process. So again, same functionality at a different slightly point. It's a different point. It's really not looking at the SDLC itself.
Awesome. Okay, so the next one, how big of a deal is something like a Jenkins plugin? How likely is that to be used in an attack? I can take that one. I guess that was.
Oh, okay.
You want to take that one?
Oh no, you go. Go ahead. Go ahead.
Awesome. All right. Well, keep me honest if I miss anything. So my take on it is these things actually happen. We just saw in July that it did happen. There was, a couple of dozen, maybe 29 of these things that had a total of 34 vulnerabilities in them. Every couple of weeks you see some sort of component that has a security advisory. It's not always a Jenkins plugin, but I guess, if we took that idea that Julie said at the very beginning, which was that attackers are kind of shifting their focus, and they have shifted it from well-fortified applications to the software delivery pipelines. And then, right now, most of that action is on open source libraries, but they're, very likely to shift it again to things like these components where there, frankly, aren't any security controls. People just don't have the capabilities like that we've talked about today implemented, and so it's wide open. And I think that it is actually likely, and it does happen, and we'll see more of it in the future because, frankly, people aren't able to defend against it right now. I mean, Julia.
Yeah. If I can just add a piggyback onto that, I think there have been some instances where attackers have intentionally installed plugins as a backdoor in, right? So they know the plugin has a vulnerability, they install it, and I don't mean to pick on Jenkins because it happens with all sorts of different plugins, but Jenkins, for example, lacks fine-grained authorization, and so you can get a credential and you can basically install any kind of plugin you want. So once you get into that account, it's an easy way in. So it's happening. It's happening a lot more than we think.
Cool. Let's see here. Next question. I guess we'll start with you this time, Julie. How developer friendly is a tool like pipeline composition analysis?
Well, I think because pipeline composition analysis is a superset of software composition analysis, it has the same integration and developer-friendly workflows. So, think about, scanning at various points, right? You can scan as part of a pull request and block a merge if you want to until a developer fixes a vulnerability or finds a better non-vulnerable library. I think also, things like two-way Jira integration, so you can open and close tickets from within, the system, are really common. So it's as developer friendly as software composition analysis is. I think there's parity there.
Awesome. Next one. Do communicating APIs constitute a dependency? I mean, given the definition that I was talking about earlier, it probably would. It's not something that's currently under the purview of pipeline composition analysis, although, it may end up there someday. There's a lot of tools that can help you with that, though. So while, yes, they may be a dependency by the definition I was given, there's API security tools that would do a better job there. Calling it what it is. Another one that came in. So Joe said, "You guys rock. This is the best explanation I've heard of software supply chain." Thank you. Appreciate that. Not a question, but appreciate it nonetheless.
We like compliments, right?
Totally. Next one. Are you saying that PCA is able to prevent all software supply chain attacks just by looking at pipelines? Julie, do you want to take that one?
Yeah, so I mean, I think like going back to PCA as kind of like a better version, you know, SCA and steroids, it protects one part of it. Um, it's a really important part, but it's just one piece of the puzzle. So, you know, you need SAST to look at your proprietary code. You know, you need to be scanning your IAC, right? So that's kind of the scanning part. But then you also need to be hardening your tools and looking for hard-coded secrets and leaks that might also expose you in your software supply chain. So, you know, it's a multi-layered, multi-tiered approach that you need to take. PCA is very important, but it's one component among several others. Anything you have to add, or?
I couldn't agree more. I mean, you know,
Okay.
the good news is that so PCA is a very important piece, but there are platforms, you know, like us, but there are other platforms out there that offer a lot of the other pieces that you would need. So this is an important part, but you know, look for a software supply chain security tool that will give you the other parts you need to plug all the holes. Okay, we had one more question, which is a perfect segue to kind of wrapping up our segment. So the question was, you know, where will you be posting this video? And I guess technically the back half of the question was, what can you enable subtitles? I don't know if we can enable subtitles, but we will be posting this both on our website, and everybody's going to get an email within 24 hours that's going to offer you a link to download the recording in case you need it. If you want to learn more, check us out at scicode.com. You can also spin up a free trial at scicode.com/free trial and, you know, kick the tires and see how it works for you. You know, kind of explore the ins and outs of pipeline composition analysis. So I guess I want to thank everybody. Julie, thank you for your time. And then everyone who attended, thank you for attending and sticking with us this far.
Thank you.
Thanks.